So as we're thinking about data visualization as it relates to illustrating or showing patterns, it's worth having a conversation about complexity, because really what we're talking about is adding in additional layers of complexity into our data visualization to be able to illustrate those patterns. And I think about how that can be done and how it can be done well, and some of the pitfalls I think is really important to be able to design in a way that communicates information easily to folks. So there's a variety of graphs that you can use. As we've talked about, there's maybe too many potential graphs that we can use. But if we're interested in communicating interval ratio data or continuous data, data that has lots of values, along with categorical information, right? So I'm trying to show a pattern between one continuous variable and a categorical variable. I can use a box and whisker plot where I've got sort of my different categories and then the distribution within it. If I may be looking at things over time, maybe I'm adding a third dimension, maybe I can do an area chart or a line chart. Again, where I'm using color to differentiate my categories, and then the continuous data is presented sort of over time. If I'm working just with continuous variables and I have two of them, then maybe scatter plots make the most sense. If I'm working with two continuous variables and I maybe want to add in another third continuous variable or a third categorical variable that's sort of lined up ordinally, maybe a heat map makes the most sense as a strategy to communicate that. So there's lots of different visualization tools that we can use that can show patterns, and we can keep adding in variables and more information in to create complexity. And that kind of gets us back to this graphic that I've shown before, that when we're thinking about complexity, we can increase the complexity of our graphs by making the dimensions more continuous, right? The more continuous dimensions we have, the more fine-grained detail we have, right? So looking at not just age categories, 18 to 25, 25 to 35, but looking at age itself, right? That requires a different visualization strategy that might be require a little more thought to do well. But then we can also increase complexity by adding in more dimensions, right? So I'm looking at more subcategories, or I've added in a third variable into my story. And while we can do these things, and there are a lot of tools to do them, I would sort of return to the cautionary note I've offered time and time again, which is just because we can do something with data doesn't mean it makes for good data visualization. And so we should think carefully about some of the pros and cons and trade-offs with different strategies for increasing complexity. So one strategy that I'm actually pretty positive about in terms of adding complexity to our data is with filters or slicers. And so Excel has both of these, and other programs do as well. But the idea of the filter is that I have my data and I can say, I just want to look at these subcategories, and it'll hide all the other stuff. And so I can just look at the information related to those subcategories. Slicers are sort of a more interactive way of doing that. And so actually we have a project in this class where we will take a table of data, we'll create a graph out of that, we'll add in a slicer and say, within this table, we're interested in just looking at these regions. And so you'll be able to click onto a region and have the graph instantly update for information just about that region. And that can be really useful as a way to add, I guess, that drill down idea that we talked about with dashboards, that you can look at subgroups very quickly and very easily, and that can allow for us to get more information out of our data in a richer way without sort of overwhelming ourselves, because we can make the choices about what we look at. But that requires that we have sort of an interactive environment, right? Whether that's a dashboard or whether that's an Excel sheet. That doesn't work particularly well if you're, printing something or sharing a PDF where you don't have that sort of dynamic ability. So there's other strategies that we can use. So one strategy is to combine two different types of graphs together. All graphs have sort of strengths and weaknesses. Maybe combining graphs together creates something new and visually interesting. Maybe it's interesting, but it's not necessarily intuitive. And so I think this is an example of that here, where we have a scatter plot, and then we have also have the histograms for the two variables that go along with it. I've never really seen a graph like this. I don't know what to look for or how to necessarily analyze it. What's a normal or common pattern? What's an unusual pattern? So this can give us more information in the same picture. But again, anytime we're moving in the direction of complexity, think about whether or not this is helping your audience understand what they're looking at, or whether we're just being fancy. This is a strategy I think actually does a really good job of moving us toward greater complexity, but doing it in a way that your audience can very quickly figure out what's happening. And so this is presenting, I guess we've got 12 different scatter plots, but they're organized as a table. And so the columns in this table are presidential election years. So I think 2000, 2004, 2008, and maybe, yeah. So we've got presidential election years. And then our rows are different regions of the country. And so we can see how over time we saw patterns change at the regional level. And once you sort of orient yourself to that table, which should be pretty easy, particularly if you add some column headings and row headings, it's very easy to sort of pick out and look at the different patterns, and probably much easier to do this than trying to explain it in text, what's happening across all these different patterns. And I'm not sure of any other strategy I could even come up with that could communicate clearly what's happening with 12 different scatter plots, other than to organize them in a table like this. A strategy, I'll put this maybe under my not so thrilled way of working with complexity, is to use multiple axes. This is something that is done frequently. The Economist magazines sort of frequently will do this, where they'll set up two different graphs and overlay them on top with different axes that they think maybe helps to tell a more interesting story. This is oftentimes done poorly because it's not always clear that things are moving in similar increments, in similar levels of extreme movement. One change, it could be small, and one dimension might be very large. In our other dimension, you also have to sometimes get creative with the sort of direction of the axes. So in this one, we've got at the top, it starts at 0 and it counts down to 400, which is kind of a weird way to display things. But on the left, it starts at 20 and counts down to 0, which is, so it ends up with both graphs sort of sloping down, but really one is going up and one is going down. And it takes a lot of energy mentally to kind of figure out how these two things sort of line up. And if your audience is spending time trying to understand what the heck your graph is doing rather than what the story is in your graph, that's not a good data visualization strategy. So I discourage people from going this route, although I have been guilty of it a time or two on my own. And then another strategy for adding sort of complexity into your story, sort of adding in additional variables and information, is to think about color, right? So this is or symbols or size. So this is a scatter plot, basically, income and life expectancy. And this comes from the Gapminder website. And it's a scatter plot. So it's communicating two interval ratio continuous variables, but then there's also color. And so if you look at the map, you see that the pink dots represent countries in Asia, or I should say the southern part of Asia and the Pacific. The blue is Africa, the green is, I guess, the whole of the Western Hemisphere. So we're adding in sort of the region of the world that this information is associated with, and maybe that's helpful. We also have the size of the dots, right, which are representing population. And so it's not surprising that the two largest dots here are pink and would correspond with China and India, two most populous countries. And so we're adding in sort of a fourth dimension, not just region and income and age, but also population. And then there's a fifth dimension that's added into this graph as well. You can't necessarily see it because it's static. But in sort of gray behind, you see 2018. This is data from 2018. And there's the ability to animate this. So you can see the change over time as well. And so again, these are ways where we can now essentially present information on 5 different dimensions: change over time, population, region, as well as our original 2 of income and life expectancy, all within one graphic. And I think that it comes through quite intuitively. That it doesn't take a whole lot of time to see the pattern or to orient to what's happening. And that's really a good sign of thoughtful and well done data visualization.